Okay, so we are now going to go over the phases of matter, and then we'll move into classifying matter. This is definitely a review. You've had this before in 6th grade, and a lot of it's going to sound familiar. On the screen, you can see the 4 phases of matter: solids, liquids, gases, and plasma. Your children will actually learn about the 5th state of matter, which is wave matter, and we'll talk about that in class. All right, so it says thinking like an alchemist. An alchemist is what you were called before you were a chemist. And an alchemist was thought to be kind of like witchcraft. So maybe an emperor would say, I want you to create a potion, an elixir that can help me live forever. And I want you to have it for me by this date. And they had to do it. They had to find a way. And so they would do their best, and they would end up giving them some kind of a potion. And the emperor would drink the potion and likely die from it, and then the alchemist would be put to death. So it wasn't a fun job. Another thing they were commonly asked was to turn regular rocks into gold. You know, somebody wanted to either live forever or be rich. Okay, so some of the vocabulary that an alchemist should know. Matter, it's anything that has mass and takes up space. Inertia, a property where matter resists the change in motion, it should say, not matter, a change in motion. In other words, when you're driving around in your car and the car has to come to a stop, because you're made of matter, you resist stopping, you keep going, and if you didn't have a seatbelt on, you would go out the window. Okay, so that's what inertia is. So you should pause right here and write those 2 things down and know what they are. Remember, though, that this word should say motion. Okay, so it says, which of these does not matter? So really think about it. Is it a snowflake, hot air, or an atom? Which one do you think is not matter based on the definition of matter? You can pause it and think about it as long as you want to. The answer is they all are. Up here you can't see it, but it says tricked you. Every one of them are matter. They all have mass and take up space. Okay, physical properties. We're going to break down physical and chemical properties, and you're going to be doing lots of experiments on these. It says physical properties can be observed without changing the matter. So if I started with water, I still have water, but I can freeze it, I can melt it, I can change the color of it with food coloring, but it's still water. Those are physical properties. And these are the very specific ones that you have to know. Conductivity, which means allowing heat or electricity to get through. A state is a physical form. In other words, is it a solid, a liquid, a gas? Water can never be a plasma. In fact, rarely anything can. Solubility, can it be dissolved? Ductility, can it be twisted into a wire? Malleability, can you hammer it into a thin sheet like metals? Make sure you pause it and write down all these vocabulary words. Remember, if you're visual, just get a good picture, but it has to be something that really helps you to remember what it really means. Okay, a physical change is a change that affects one or more of the physical properties. In the picture, we see the man who looks like he's melting. This is just a painting illusion. And then also this ripped piece of paper. Another example would be mowing the lawn or cutting your hair. It says, which of these are physical properties? Color, rust, or shape? The one that is not a physical property is rust, because once something rusts, you can't get the original thing back. Okay, chemical properties. Matter's ability to change into a new form of matter with new properties. Chlorine all by itself that you were going to put into a swimming pool would be poisonous and harmful to humans. Sodium all by itself bursts into flame when you touch it to water. But when we put them together, they change into a totally new form of matter with new properties called table salt, and it's perfectly fine if we eat it. 2 of your more common: flammable, being able to be burned, and not everything can be burned. Reactivity, the ability to bond with something else or combine with something else. Again, make sure you pause it and write these things down. A chemical change is another term for a chemical reaction. These are the 6 things that show you a chemical reaction is taking place. The odor changes, maybe a sweet smell, or if you were burning sulfur, the smell of rotten eggs comes out. It gets heated up or very cold, like the one you did last week. It fizzes or creates a gas. It starts to foam. You hear sounds popping. It lights up. Okay, so these are all things of chemical change. It says in this chemistry humor, I told you we shouldn't have gotten him that chemistry set because he turned his dad into a pig. We'll go to that would you rather in class. Okay, physical change can be easily reversed. So if I freeze water, then I can easily melt it. But a chemical change usually can't even be reversed at all. If I cook a cake, I can't get the dough back. I can't get the batter back. It's once you go through a chemical change, it's very hard to go backwards. All right, states of matter. It says also called the phases of matter. A solid has a definite shape. It doesn't change its shape just by sitting there. It stays the same and a definite volume. The atoms are all tightly packed. That's the reason you can't put your hand through a solid. An amorphous solid would be the only one that can change its shape. So it acts like a liquid. It morphs itself into a different shape. Your example would be slime, jello, things like that. A liquid has a definite volume. I can measure out 10 milliliters of a liquid, but it doesn't have a shape. It takes on the shape of whatever container it's in. The atoms are loosely packed, so now you can put your hand through the liquid. Viscosity is just a vocabulary word that means resistance to flow. In other words, it doesn't want to flow. So honey is very viscous. It doesn't want to flow. And water is not. It has a low viscosity because it flows easily. Make sure you're writing down in some form all of these vocabulary words and what they mean. A gas doesn't have a definite volume or shape. I can't say, get me 10 milliliters of a specific gas. Atoms in a gas are very far apart. We can walk through gas easily. We don't even notice the air around us. Boyle's and Charles' law, you don't really need to know them. You don't need to write these down. This just shows you that as something gets smaller, pressure goes up. If you blow up a balloon and you squeeze it, the pressure goes up. It's going to pop. Charles' law says that as temperature goes up, the volume goes up. So think of that flat basketball in the winter. Because the temperature has gone down, it's flat and you can't even bounce it. Okay, it says, which would you say a crowded hall at our school is most like, a liquid, a solid, or a gas? Now, if you can't even get through at all, we would say it was a solid. If you could barely get through, you would say a liquid. Definitely not a gas. Plasma is made of charged atoms, they're ions, meaning they're giving off some kind of radiation. It's very rare on Earth. Lightning is the only example. But in the universe, it's abundant. All the stars are made up of plasma. Okay, phase change is a change of state. It says this only occurs as the atoms movement changes. It's not because of temperature, because freezing and melting occur both at 0. So as the atoms slow down, it starts to freeze. As they start to move faster and faster, it melts. But they both happen at 0 degrees Celsius, and you should write this down. Melting is from solid to liquid. Freezing is from liquid to solid. Evaporation occurs like in your fish bowl or maybe your swimming pool. The water at the top, the liquid, changes to gas, and then eventually you have to add more water. Boiling is also liquid to gas, but it happens at the bottom of a container. If you look into a pot that's boiling, you can see the bubbles all forming at the bottom. Sublimation is when a solid goes to gas. This would be like dry ice, like what's in this picture right here. And condensation is when a gas, air, changes to a liquid. This would be like dew on the grass or the condensation on your glass that has a cold drink inside of it, and the air gets cooled down and becomes liquid drops. Make sure you're writing all of this down. we're going to skip that. This diagram we will actually do in class, so don't worry about it right now. And that's it as far as the notes goes. I hope you're ready to do lots of experiments and different activities in class. I will see you on Tuesday.